Hello, everyone. First, thank you for joining us this morning. Today we have HashiCorp's very own software engineer, Becca Petrin, here. She's going to demonstrate how the best practices for using HashiCorp Terraform with Vault and demo some of the features you can utilize with the two. We will then spend the last 15 minutes of the webinar dedicated to Q&A. I do want to reiterate that this webinar is recorded and will be available to you post-processing, usually within a day or two, so look out in your inbox. In the meantime, there is a questions box. Feel free to put your questions in there and we'll get to them at the end of the webinar. With that, we'll get started and off to you, Becca.
Cool, thank you. All right, let me get my screen shown. Let's see here. Okay. All right, there we go. Okay. So hi, my name is Becca Petrin and I'm a software engineer on the Vault team. I've been with Vault since February of last year, and I am also the engineer who maintains the Terraform Vault provider, which has led me to do a lot of thinking about how Terraform and Vault work together. What are they both good at? Where does the responsibility of one start and the other end? Because of that, today we're going to cover best practices on how to use Vault and Terraform together. We'll cover how to use Terraform to spin up a real Vault cluster backed by Consul and running in AWS, and how to do this in only 5 minutes. And then we'll configure Vault and use Vault to feed further secrets into Terraform. So being a Vault engineer, my main focus is security. On the Vault team, we passionately believe in the importance of protecting sensitive and secret data. And so today we're going to show you how. I hope that by the end of the presentation, if you are new to these tools, you can take away a couple of tips on how to get going with them. And if you're not new to these tools, I hope that you can take away some tips on how to do what you're already doing, but more securely. So the sections that we're going to go through today are these. In getting started using Terraform, we'll start by spinning up our cluster using this pre-created Terraform config that is available to you. In recommended architecture, we'll take a look at the actual architecture we'll be spinning up and how it works. In seeding Vault with secrets, we're going to cover not only how to get secrets and sensitive data into Vault, but how to protect those secrets against loss. And finally, in consuming those secrets, we'll cover how to use Terraform for further infrastructure on your team. I've chosen AWS for this presentation mainly because I'm most familiar with it, but all of these actions can be taken on any platform, including GCP, Azure, or AliCloud. And also, I'm going to kind of use some tools here and there. And at the very end, I'm going to show a slide that has the links to all of the references that I'm using so that you can copy what I'm doing at your workplace. But before I start, we're going to have people at many different levels here. And so some folks who are more familiar, there will be some folks more familiar with one thing than another. So I wanted to give like a quick vocabulary drive-by. Terraform is a cross-platform tool for writing infrastructure as code, which we'll be using to create resources really quickly. Vault is a cross-platform Swiss Army knife for protecting against data leaks. Consul, as Vault uses it, is a database for storing secrets in an encrypted format, but it's also a wonderful service mesh tool. And finally, AWS is short for Amazon Web Services. We'll be spinning up our cluster today on Amazon EC2 instances. Everything that we do today is going to be using the open source or free version of all of these HashiCorp applications. But once we spin up our Vault cluster using AWS, running these applications on AWS does incur a cost, and it would on any Google Cloud or any platform. And so be thoughtful of that as you follow along. When you actually run the Terraform apply command, that is when you would be spinning up real resources that cost real money. Okay, so getting started using Terraform. So in just a moment, I'm going to begin spinning up our recommended architecture. I'm going to let it run over the course of 5 minutes while I'm telling you about it, and then we'll circle back to it and we'll continue setting it up. What I'm going to do on the bash command line here is I've actually already run this AWS configure command before our presentation. What it did is it allows me to add AWS an AWS access key and secret to my shell environment. And the ones that I configure here, they're going to be used by Terraform to spin up those real AWS EC2 instances I mentioned earlier. Then when I run git clone in a moment, I'm going to pull down some pre-made Git code from GitHub. This is from a public repository that you can access. And then I'm going to change my directory into the best practices architecture section, and I'll run Terraform. There is one change that I'm going to make before I run this code. I'm going to change it to use the AWS S3 remote state backend. So what is that? Well, whenever Terraform runs, it spits out this file that records all the things that it created so that the next time it runs, it knows what's already out there and what it needs to change. And so that file is called the Terraform state file. The Terraform state file often includes sensitive data, and by default, this file is added to your own laptop for you to see. So to prevent that file from becoming a possible attack vector, instead of putting it on my own laptop, we're actually going to protect it by instead telling Terraform to put that file into an encrypted S3 bucket. So I'm going to add it to my Terraform config before I run it. I would recommend using state file encryption for Terraform anytime there's a long-lived secret in your Terraform config or state. In this case, the AWS key that I'm going to be using, it's going to live for a good amount of time. So that is why I'm using state file encryption in this case. AWS does recommend that these keys and secrets are rotated periodically as well, and we do agree with that recommendation. So I'm going to go ahead and get this started. We're going to come on over to the terminal. All right. Just getting my terminal up here. All right, great. So you should be able to see that now. Okay, so let's go through those commands that I just talked about. So I am going to go ahead and pull down that pre-made code that I wanted. And I'm going to change into the directory where the code lives that I'm going to use. I'm going to list the things in here so you can see what's here. So what we have are some Terraform config files that have been pre-made for you by the team here at HashiCorp. And these are for spinning up a best practices cluster on AWS. Now I'm going to actually edit that main.tf file to use the remote state backends that I talked about. So nano main.tf. I'm going to add it right here to the top. And I'm going to save it. And then I'm going to run Terraform init. Terraform init obviously initializes Terraform. What it's doing right now is looking inside all of the config files that were here in the directory that I showed you. And it's saying, oh, what code am I going to need in order to run this? And it's pulling down all of these different plugins for Terraform that will spin up Vault and Console for you and in the AWS environment. So now that's done, and the last thing I'm going to do is run Terraform apply. And this is where it's pulling my Amazon config, my key and secret. It's asking me, of course, what region I want to be spinning up resources in, and I'm going to use US East 1, which is a very common region to use because it's the one where AWS rolls out most of its features first. And then it's saying, so what it did right there is it looked at Amazon in region US East 1 to see if I already had any of these resources that I'm asking for it to create. And it saw that I don't. So it's planning to add 127 things, and it doesn't have any to change or destroy. And it's asking me if I really want to do this. Now, if you type yes here, this is the part where it spins up real resources that cost you money. So do this thoughtfully. I'm going to go ahead and hit yes. And Terraform is going to get to work spinning up all those resources. Meanwhile, while it's doing this so that we're not just watching a whole bunch of text swirling across the screen, I'm going to go over and I'm going to tell you about a little bit about what Terraform is doing. So let's go back over to the presentation. Let me get it up again here. Here we go. All right. So recommended architecture. What is Terraform doing right now? It's spinning up a single data center for Vault. The cluster that we're going to be looking at today is 7 total instances, 3 of them are Vault servers, 3 are console servers, and they're protected by a Bastion host in front of them, and thus they aren't directly exposed to the internet. A Bastion host is a special purpose computer on a network specifically designed and configured to withstand attacks. The computer generally hosts a single application, for example, a proxy server, and all other services are removed or limited to reduce the threat to the computer. Vault is further ready to withstand attacks. It encrypts all secrets in transit and at rest. So if someone were to try to look up Vault secrets directly in console, they'd only see the encrypted version of the secrets, not the secrets themselves. So please note that once these instances are up, we do recommend that you also walk through our production hardening guide. It will take you through further steps to complete once they're set up, such as turning off core dumps, enabling auditing, and disabling the shell command history. We're not going to do that today, though, both in the interest of time and because the production hardening guide it's very straightforward to follow, and so there's not a huge benefit for to have me walk you through it today. Now, once these instances are up, how will they fit in to how we're going to use Terraform and Vault together? So in the HashiCorp stack, Vault is absolutely the only place where your secrets and sensitive data should be managed. When members of your team are using Terraform to spin up additional resources, we recommend that you have them authenticate to Vault using an easy auth method like GitHub, get a Vault token specific to them, and then run Terraform with their individual Vault token, pulling all the secrets they need directly from Vault. We'll give a specific example of that later, but I just wanted to start introducing you to this idea. But basically, 1, you can use Terraform to spin up your Vault cluster. That's what we're doing right now. 2, a highly privileged person should place secrets into Vault and configure access to them. We're going to do that in just a moment. And then 3, people on your team using Terraform should use it with their individual Vault token and with no secrets placed directly in the config. And we're going to look at that workflow in a moment as well. It's pretty simple workflow. It's actually pretty cool. So this might give rise to a question. If secrets aren't in the Terraform config, then how are the secrets in Vault backed up? Well, we recommend using Console's snapshotting mechanism to save and restore the encrypted Vault data that has been placed in it. This will allow you to save and restore Vault secrets while continuing to keep them in a safe and encrypted format. That way, although they're backed up and they're recoverable, they're also still not in plain text anywhere. So it's very secure, it's very nice. All right, so now the architecture we've been discussing should have finished spinning up. Let's go and take a peek inside our AWS console and see what is there. All right, we're gonna get out of this presentation for a minute, go right over to AWS. Oh. And let me go ahead and refresh this. There we go, that looks about right. Okay, so right here, you can see that we've got 7 instances. There are some other instances that are unrelated to what we're doing today because we use this account for testing. But basically, we've got our best practices architecture up now. We've got 7 instances. We've got a Bastion host, 3 console nodes, and 3 Vault nodes. A couple other things to notice about this are that the instance type is a T2 small that we're using. I'd like to clarify about this that this is not our recommendation. These are just some really small instances to keep the cost down for when you're initially playing with our best practices cluster. We actually recommend M5 larges as the instances that you would use in a real production environment. So you would just edit the Terraform config to have that. We do have a architecture recommendation website where you can read through all of the recommendations for the instance sizes and then decide what best suits your own organization. I'm going to link it at the end, but you would want to change that before actually spinning up this architecture. Another thing you might notice is that we don't have everything in the exact same availability zone. We did that on purpose. The reason is that if one physical data center goes down, we want to be able to have redundancy. And so that's why we've got things in 1A, 1B, and 1C over here in the availability zones. So, okay, let's go ahead and see where Terraform is at right now. Let's return to our terminal. Let me get you to the terminal here. All right, here we go. All right, so we're back to the terminal where we were running Terraform. It's finished up and stopped, which is awesome. So I'm going to go ahead and continue getting this set up. So when you actually spin up a Vault instance, it comes up in a sealed state by default. That means that it's not serving any web traffic. The reason that we do that is because we want to make sure that nobody's spinning up an instance out of band at your company that you don't know about. And so whenever an instance comes up, it has to be unsealed with these particular keys. The first time that you unseal it, you're given these keys and an API token to get started. And so we're going to go through that process right now. And I'm doing this all live so that you can follow along. So the first thing we need to do, we get these instructions on how to interact with our new Vault cluster right here. So it's created some SSH keys for us to use. The first thing I'm going to do is go ahead and add the SSH key to my keychain here on my Mac. And then the next thing I'm going to do is I'm going to use that SSH key to actually head into my, my Bastion. So here I am popping right onto the Bastion here. Do I really want to connect? Yes. And so you can see from my command line that I am now on the Bastion host. That's why I've got this little intro here. And so now that I'm on the Bastion host, I have access to getting into my Vault servers where I'm going to go to initialize Vault. So I do have another command here that will get me right onto those. It's this. I'm going to copy that and paste it. And this is asking me if I really want to go. Yes, I do. Okay, so you can see here I'm no longer on the Bastion. I'm now on a Vault node. And so what I'm going to do to start off is run Vault operator init. This is going to give me my first time unseal keys and my initial root token. In real life, you would distribute these to 3 people, and then you would do your initial setup and revoke the root token. I'm not going to go through all of that today because that's not the main focus of this particular presentation. But I am going to record these unseal keys here, and then I am going to use them to actually unseal Vault on this node. So that would be Vault operator unseal. So I'm going to do this with 3 different keys here. And finally, the third one. Okay. So now we can see right here that it's not sealed anymore. So that's one of our 3 Vault nodes. We're going to do this with 2 other. Please bear with me. This will take about 3 minutes max, I would guess, to unseal these other 2 nodes, and then we'll get back to the more exciting part of our presentation. But the reason I'm doing this live is because I really wanted you to see exactly how you would do it so that if you are following along on your own, that you don't have any points where you might get stuck, basically. So I dropped back down to the Bastion host by hitting Control-D. Now I'm going to go into the second Vault server by going like this. It's going to ask me if I want to do this. And I'm going to do Vault operator unseal here as well with 3 different keys, which I've recorded over here. Okay. And let me get that last one. All right. So now we see that this is no longer sealed, and we've got one more node to do this on, and then things will get more interesting again. All right, last one. Okay, that's 1. 2. And the last one. Okay. Okay, that's it. We literally have a Vault cluster up and serving traffic now. I'm going to hit Control-D again to drop right back into my Bastion host. And the last thing I'm going to do to get ready to start setting up Vault further is I'm going to add a Vault token here. the vault token that was given to us earlier. So I'm going to do export vault token is equal to this. And there we are. Okay, great. So let me get back over to our slideshow. Just a moment. And we'll continue talking about all of this and what we're doing and why we're doing it. Okay. Let's see here. Okay. Thanks for sticking with me there. Okay. I've almost got this showing. There we are. All right. So now we're going to get into seeding Vault with secrets. But before I do, I want to kind of give you a high-level overview of what I'm doing and why I'm doing it, because that's really the more important piece of the context to take away here. So basically, the way that we're going to be setting this up is, let's say I have an engineer on my DevOps team. Every morning, she will come in and authenticate to Vault using her GitHub API key. In return, Vault will give her a token to use for the day, and that token will expire when the day is done. That's what I'm setting up here. So then once she has the Vault token, she's going to export it as an environment variable rather than putting it into her Terraform config. When she runs Terraform, it'll use that token to get further secrets from Vault. In this example, Vault will be giving her some unique AWS keys that will expire in 5 minutes. But really, she could get all sorts of things from Vault, like database passwords, for instance. So when she actually runs Terraform apply, it's going to pull these database passwords or AWS keys, and it's going to put them right out to the state file. But guess what? In 5 minutes, poof, they're worthless because I'm going to set them to expire in only 5 minutes. Now, if they're expiring in 5 minutes, this might make you think, oh, well, what about later in the day? Won't that be a pain to use Terraform again? Because she'll have to get the Vault token again. The answer is no. The token lasts for 24 hours. So that's just going to, she only has to log into Vault once a day. But then she can run Terraform over and over again. And if it's using a secret that has expired, it's just going to pull a brand new one from Vault. So these Amazon keys and secrets are going to be dynamically created on the fly every time she uses Terraform. So yeah, that's basically the workflow. Note that in this workflow, 0 secrets live in the Terraform config file, and that means they don't have to be committed to GitHub or anything else that holds secrets. They live only in Vault. GitHub, of course, isn't the only way to authenticate to Vault. You could use a different authentication method instead if your continuous integration system, for instance, needs access. But that's kind of the general idea. The other piece of this idea is like, why would I do this? Well, why would we set it up this way? Well, when your DevOps team gets access keys and secrets through Vault, they're short-lived and they're unique to that person. You can set them up to be valid for only an hour, a day, a week, or any amount of time that you'd like. And also, AWS keys aren't the only secrets that Vault can hold. It can dynamically create short-lived credentials to your databases, to GCP. It can give SSH access and a host of other things. Centralizing all of this in Vault means that you'll be able to create an audit log of every secret that's being accessed, by whom and when, which is fantastic for your security compliance story. And then someday when that DevOps team member moves on to some other company, by removing them from your GitHub organization, you will automatically remove their access from everywhere. And you can also go into Vault and revoke any credentials that they currently have checked out. And since they will only have been issued to that person specifically, there's no issue with revoking shared credentials. So revoking their username and password to your SQL database, it won't affect anyone else. So these are all very good things. Some of the most famous attacks in history have been insider attacks, and this protects your organization from one. It's not necessary anymore in this scenario to give your developers the keys to the kingdom. This also protects against accidentally leaking secrets, because even if your DevOps member doesn't encrypt their Terraform state file and it's seen, all the secrets in the state file were dynamically created in Vault and set to expire, and then the scope of the problem is limited. So this protects you even if your Terraform state file is leaked. How well it protects you basically depends on how quickly you've set those secrets to expire, we recommend that you set them to expire very quickly so that basically they can be used only once by Terraform. Also, I'd like to let you know that the reason I'm going to do all of this at the command line is we do have a user interface made by our talented front-end engineers. It's available in the open source version of Vault. But today I'm going to be configuring Vault using the command line because out of the box, our quick setup cluster is designed to be accessed from our Bastion host. However, turning on the UI is a simple flag in your Vault configuration, and granting access to it can be done by having your developers on the same AWS VPN. So let's look at what I'm going to do here. First, I'm going to enable the GitHub auth method so that my DevOps team can get their Vault tokens using their GitHub identities, as long as they're members of my organization. Please note that there are many other ways to authenticate to Vault, including but not limited to OIDC, which is like OAuth, or a username and password. I've just decided to show you GitHub here because a lot of the time, the people who use Terraform at an organization also do have GitHub accounts. And then once I've made it so that they can authenticate to Vault using GitHub, I'm going to make it so that they can get an AWS key and secret for use with Terraform. And basically what this is going to do is I'm making it so that when these DevOps team members, when their Terraform config looks at the path of AWS roles dev-role, Vault is going to create a new AWS key and secret for them to use that expires in only 5 minutes. So that's what I'm on about here. And let's go ahead and head over to the terminal and actually do it. Just flipping right over here. Okay. Here we are, looking at the terminal. Okay, there. You should be able to see it now. All right, so first I'm going to create a policy. That's this right here. This policy basically says that anybody who has this policy available or applied to them is going to be able to read creds from the path of AWS creds dev role. And that is the path at which Vault is going to dynamically create a new AWS key and secret for them that expires in only 5 minutes. Okay, now I'm going to enable the GitHub auth method. So that's what I'm doing here. So right here on this line, I enable the GitHub auth method. Here, I say that it can be used by people at the HashiCorp organization. And this TTL here is basically 24 hours. It's saying that whenever Vault gives somebody a token using this auth method, it should last for at most 24 hours. And then finally, on this line here, I'm saying that whenever somebody uses GitHub to authenticate and they're a member of the Vault team in GitHub, then apply this dev policy to them, which again is this policy up here that makes it so they are allowed to read from this path in Vault. They're not going to be able to see literally anything else in Vault because this is all of the privilege that they have inside of Vault. So the other piece of this, as I had mentioned before, was enabling the AWS secrets engine. I'm going to do that. I'm going to clear this up so it's a little bit easier to see. And I'm going to paste in all this. So basically here, I am enabling the AWS secrets engine. I'm telling it that when it talks to AWS, it should use this access key and secret. These are variables, command line variables. I've put my real access key and secret behind them, but I don't want to show them on this webinar, as I'm sure you can understand. And then here, this is where I'm setting the credentials that are made up for, like the AWS key and secret. I'm setting them to expire in only 5 minutes on this line right here. And then finally, here with this whole thing, I'm saying when you issue credentials, I want you to grant them these privileges inside of AWS. Those are the privileges that they should be able to do. So that's pretty much it for setting up Vault for this workflow that we're going to be doing here. Let's return to our presentation. So I'm going to flip back over to our presentation here. Let me get it back up on the screen for you. Okay, so then last piece of this puzzle, now that we've set up a best practices cluster and we've seeded it with the ability to log in and get secrets, we need to actually know how to consume those secrets. So let's talk about that. This is an example of a Terraform config file that a DevOps team member will have. At this point, whether they're using remote encrypted state doesn't matter because the AWS secret they'll be consuming is so short-lived. Please do expand this analogy to all the secrets that are needed in the Terraform config file. Every secret in the Terraform config can be retrieved from Vault. Vault can create unique short-lived secrets for Active Directory, Ali Cloud, AWS, Azure Console, a huge array of both SQL and NoSQL databases, Google Cloud, Nomad, it can do secrets for use in SSHing, and more being released every day. So if you already use Vault but not Terraform, this is how to get started while maintaining your security story. If you use Terraform but not Vault, I invite you to consider Vault as a way to strongly protect the secrets in your Terraform config and state. Terraform excels at providing infrastructure as code, and Vault excels at protecting secrets, and together they're like peanut butter and jelly. Let's see. I wanted to show you also this method of pulling secrets straight out of Vault. This one showcases Terraform's ability to pull secrets from nearly anywhere in Vault. Earlier on, if we had also configured a secrets engine that gave a short-lived username and password to one of our databases, like Postgres, for instance, then this is how we would pull credentials for use in Terraform. Again, this means that Terraform's resulting state file would be harmless in 5 minutes if the username and password had been set up to expire in 5 minutes. If there were any long-lived secrets in the Terraform configure state, I would again recommend using the AWS remote state instead, pointed at an encrypted S3 bucket as I showed earlier on. So this is where it all ties together, and we take a look at the workflow of that engineer we talked about earlier who arrives in the morning. So basically, she gets in and she gets a Vault token using her GitHub identity by running this little command in her command line, and boom, the response to that first line of code is that she'll get a Vault token. Then she exports it so it doesn't live in her Terraform config file. And then when she runs Terraform apply, Terraform pulls those short-lived secrets that she needs from Vault using the config files that I gave an example of earlier. And they pretty much get pulled in, Terraform does its work, it goes out to the state file, and the state file is rendered harmless in 5 minutes. So it's that simple. 3 lines right here. All right, so in summary, we've now walked through how to quickly spin up a best practices Vault cluster, how to secure it, how to seed it with secrets, and how it can be used to securely provide short-lived dynamic secrets to your DevOps team. I hope that in this demo, if you're new to these tools, you now have some sense of what they are and how they can work together to make your life easier while also keeping security at the forefront. If you're not new to these tools, I hope you picked up a couple of tips on how to use them together. If there's one thing to take away from this, it is that we recommend that no long-lived secrets live in your Terraform configure state files. Secrets are where Vault shines, and so it's available in our open source version. Feel free to use it. All right, and finally, these are the references for you to use that I referred to inside of this presentation. The Vault reference architecture is where it talks through what kind of Amazon EC2 instances you might want to use if you use this approach and the pros and cons of various things. So I would definitely recommend using that if you're going to use this. Best practices Vault cluster on AWS. This is a link to that GitHub code that had all those pre-made Terraform templates so that you can also go and use it if you would like. The production hardening guide that I mentioned earlier for locking down the Vault instances and such is right there. And then also finally, as one of our references, I do have an example of how to pull AWS keys from Vault that's been put up by a very smart colleague of mine named Roger Berlind. He found that when he was pulling AWS keys from AWS dynamically, through Vault, sometimes they needed a moment to propagate before they could be used. And so he actually built in a little pause of a few seconds where Vault dynamically generates these AWS keys and secrets. There's a pause for a couple seconds, and then you actually, Terraform will move on and start using them now that they're available. So if you end up wanting or needing an example of that, that is right there. And that is pretty much it for my webinar today. We will be taking questions in just a moment. I want to thank you for your attention, and yeah, we're ready to welcome those questions.
Thanks, Becca. We did get a slew of questions, so I'm just looking through these right now. The first question is from Roger. Is there a module like the AWS one used here, but for Azure?
I don't believe there is one that is used for Azure that is hard, like is directly pointed at Azure. But in the on that second Terraform config file that I showed you, where it's pulling from the database secrets engine, it can pull from anywhere in Vault that supports read access. And I'm not sure whether the Azure Secrets Engine has a read for its credentials or a post for its credentials. If it's a read, then out of the box, you can use that same config in order to pull from Azure. That's what I can say about it.
Great. The next question is, in order for Terraform to pull stuff, do you need access to the internet?
In this example, you do, because Terraform is using Amazon Web Services, which is on the cloud, which is like a part of the internet. It's hosted in there. But you could use Terraform to spin up local resources on your own computer. In a different scenario, if you weren't using AWS, you could certainly use it without the internet.
Next question, is the Terraform apply step running in a single thread?
I'm not sure whether it uses parallelism by default or if it is single threaded. Because I'm on the Vault team, it's more of a black box to me. But I do think, if I remember correctly, there is a flag for Terraform that lets you control parallelism to some degree. So I think it might be single threaded by default, but I'm not sure.
Okay. We'll make sure to get back to some of the questions that we weren't able to answer during this call. Can we use the Terraform best practices to deploy Vault in a production environment?
Yeah, you could. You would want to make the edits that I had talked about earlier, but yes, the edits to the instance sizes being at least M5 larges.
The next question is a little bit broad. How would auto unseal feature work? So that's a big question that might be a separate webinar.
Yeah, that's probably a separate question, but I can touch on it a little bit. So in the pre-made Terraform config files, it adds a Vault configuration to the instances. And so what you would need to do is go into those files and change it so that it's using an AWS key. I actually think that what you would want to do is spin it up the way that it already is spun up and initialize it so you have the initial, the initial unseal keys in the Vault token. And then you would update the config to use the auto unseal method and then do a migration to use the auto unseal keys. Because Vault always does need to be initialized first, providing the unseal keys and such before you bring it over to the, for the very, very first time, before you bring it over to using one of the auto unseal methods like KMS.
Yeah, and there's also a separate webinar we did recently, which was Vault 1.1, how to auto unseal and other new features. We could send that out as well. So the next question is, for application-specific Terraform scripts, do you recommend we keep it in a separate repo along with other Terraform resources or in the application-specific repo?
I'm not gonna dare to make a recommendation on that because of how I'm a Vault engineer and I'm not on the Terraform team, and I can't speak for what they would recommend.
Yeah.
Sorry.
No
We
worries.
could research that and respond with it later, though. We could ask them.
Yeah. Um, does Terraform handle the case where an operation in AWS takes longer than 5 minutes?
The pause in the script that I linked for Roger Borland, I believe that's configurable. So you could indeed just set it up to pause more than 5 minutes.
This is a loaded question. Is Vault becoming a single point of failure?
Hopefully not, because you've got it in a cluster where you've got one active node and then you've got two standby nodes. That's why we've got the redundancy there. You know, and the Vault servers in the best practices architecture are spun up in three different physical data centers. You know, as I pointed out with the regions, and so then they would fail over to the other Vault. The active server would fail over to the standby servers in that kind of situation.
Okay. So do the master passwords for a database expire as well after 5 minutes for resources that do not allow you to change passwords? How would that work?
So the database secrets engine and many of the dynamic secrets engines in Vault, well, all of the dynamic ones, where they create a username and password for a database on the fly, they let you configure how quickly you want it to expire. By default, if you don't configure it, it's usually about just over a month. But in this example, I actively made it 5 minutes. Um, and so you can configure how long you want it to last for any of those dynamic secrets engines. And then if for some reason you did encounter a situation where you couldn't set them to expire, then you would want to use that remote state encryption in order to protect long-lived secrets and be very careful with those. But definitely the recommendation here is to use dynamic secrets in there so that they expire in a short amount of time, meaning that if the Terraform state file is leaked, then its scope of damage is much more limited.
Okay. So the next question is, can the AWS config or root be rotated?
The AWS config inside of the AWS secrets engine, yeah, you can update it at any time that you want to.
Is it possible to try Vault and Terraform without access to AWS or another cloud provider?
Yeah, so like maybe you'd be like running it bare metal or something like that. Yeah, that's totally possible. Um, Terraform could be used to spin up the resources locally on your machine or something like that. Yes, so the answer is yes. You can run Vault on anything that you want to, and you can use Terraform to spin it up. Like the whole idea is that we're trying to be cross-platform for cloud providers and also for bare metal.
Um, yeah, and I just saw that someone just asked if they can use multi-cloud providers. So they have 3 Vault servers, one on each cloud provider. Um,
Uh, hmm. I think that you could, but I don't know if I would recommend it because I would wonder how they would talk to each other. I suppose that they might need to be opened up onto the internet directly if they were to be networked together. And generally, I wouldn't recommend that Vault is directly available to the internet if it's possible. Definitely better to have a bastion in front of them. Um, yeah.
okay. Can Vault get secrets if we have multiple AWS accounts and use role-based access to switch accounts?
Yeah, the AWS Auth engine is pretty cool. It does have some different options available for how it can be used. One way is using role-based access where it's like hosted, for instance, on an EC2 instance that's been launched into a role. And then it uses the instance credentials in order to authenticate to Vault. And that's a pretty cool way of doing it. You can also do a different type of access where you have something assume a role through Vault. And so yeah, it's pretty flexible in that way.
Awesome. For secrets that are passed as environment variables, for example, the vault token, are these captured in the Terraform state file?
Yes, they do tend to be captured inside of the Terraform state file. And that is why we do set them up to be shorter lived.
Ooh, lots of questions here. To execute the vault login command, you would first need to SSH into the bastion and then to the vault instance, correct?
In this example, yes, because we were sort of like, we literally spun up the cluster on the fly. It was brand new. And so it hadn't had further setup yet. So yes, in the first example, you would need to do that. But in real life, in practice, what you would want to do is have your developer on the AWS VPN. And when they're doing that, then they can set an environment variable of the vault address, and then they can set the environment variable of the vault token that they obtain every day. And they would be able to do that then from their local computer without SSHing into anything.
Okay. Someone asked, can Consul get installed along with Vault to manage the Vault cluster? Is that Consul licensed separately?
Oh, okay. So in this example, it is spinning up 3 Consul nodes separately that the 3 Vault servers are talking to. So the answer to that is definitely yes. And yeah, I mean, Consul is available. And in this example, we're using the open source version of Consul. So even if you have like a paid Vault, an open source version of Consul will work for your use case, then yeah, go for it.
We only have time for a couple more questions. I'd say probably 3 more questions. So I'll just kind of grab this next question is, can we see the user who creates or manages the AWS resources in CloudTrail since the AWS keys are generated from Vault?
Oh, yeah, so they're generated by Vault. Vault does an API call that is captured by that's captured by CloudTrail. And so you can see it does appear to be created by the Vault user. So you wouldn't see directly in CloudTrail the person who was behind Vault who was creating it. You would go to the Vault audit logs in order to do that. So that is where it would be captured.
Just a couple of general questions here. What is the version of Terraform, and does the repo you use install Vault OSS or Vault Enterprise?
It's OSS, and the version of Terraform is the one that is out right now. It's like Terraform 11.8 or something, 0.11.8 if I remember correctly.
Yep. And so that's all the time we have questions for now. So thank you everyone for joining the webinar. I know there are a couple of questions regarding whether the recording will be sent out. Yes, again, the recording will be sent out. Usually we'll do it within a day or two. And if you want more HashiCorp resources, you could go to hashicorp.com/events. We have a couple more coming up, particularly on Consul and Vault. So with that, we're going to close out the webinar and have a great day. Thank you.
Thank you.
Bye.